Okay, here is your video lesson for synthetic division. It'll be due Monday at the beginning of class time. What I'd like for you to do is watch this corresponding video, which if you're doing that, you're doing a good job. I'm going to go through the handout and then we'll do these problems together and you can follow along with me. And then I've got the problems out of the book and then a couple of mastery problems for you to hand in on your own. Now, let's get started. So the first thing we want to establish is this concept that synthetic division is really just a trick. It's a shortcut. It allows us to do things very quickly when it comes to long division. And in order for that to happen, this division that's going on here has got to be set up in such a fashion that we have this in the form of x minus c. So this concept of x minus c, as it talks about right here, the thing that is really, that's just a 1 coefficient in front of the x. If I have 2x minus 3 is what I'm dividing by, I can't use synthetic division. Nothing is going to be able to make that work. Then we need to make sure that if you have any 0 coefficients in our dividend, we need to put our placeholders just like we did with long division. And I think you might want to look out on your mastery for one of those that might be there to trick you. If you're paying attention now, you'll know to look for that. So how this works for a shortcut is we have this x minus c, and I like to call this the kettle number. So we're going to make this little kettle over here, and this concept of x minus c right here, so x minus c, if I call it x minus 1, what we're dealing with then is that the number 1 is the number that goes in the kettle because it's in the form of x minus c. The c constant, so to speak, that number is a 1 in this case, so a 1 goes in the kettle. That's where this 1 is coming from. Right here, this 1 goes right here. Okay, then I have my coefficients that go with my original expression here. So I've got a 1, 1, negative 2, and I'm just going to write them down 1, 1, negative 2. Now how synthetic division works is the first number just falls. Don't overthink this. It's just a process. It's a set of steps. Step number 1, the first number falls. Whatever is here just falls right on down. Then we take the kettle number, 1, times the number that's here. 1 times 1 will make 1. Then we're going to do addition. So addition happens here. 1 plus 1 makes 2. And then I take the 1 times the 2, giving me 2. I add, I get a 0. When I get zeros, that's nice because the last number will always be my remainder. Okay, so following along with what happened here, we had a 1 that fell down, the 1 came down. Then I take 1 times 1 makes a 1, add them together gives me 2. 1 times 2 gives me 2 here, add them up, I get a 0. At the end of the day, these make my coefficients and my remainder of what is going to be the answer to the long division. Now, we started at the very beginning with a second degree equation divided by x to the first. So we're going to go down by 1 degree. Think about what's happening here. X, if we were doing long division, we'd put an x here because we'd say x times x makes x squared, and it would have been a 1x. That's what this corresponds to. It's the 1x up on top. And we don't need that 1 there, really. It would just be x. Then this becomes plus 2. Now the 1 that's right here is the 1 that went right there. Okay, and then the 2 that's right here is what goes right here. And this is a 0, making a 0 remainder. So our final answer is x plus 2. Let's do another example. And we'll do 3 of them here. But let's first talk about what goes in the kettle. X minus 2. Okay, it had to be in the form of x minus c. I have it in the form of x minus 2. So 2 is the number that goes in the kettle. That came from right here. I line up my coefficients. I need a 5. Come on. I need a negative 6. I need a 3, and I need an 11. Wow. Okay, now, synthetic division, don't overthink it. The first number just falls. The 5 falls down, that makes 5. 2 times 5 makes 10. It's just a process. 10, we're going to just add these up. Okay, negative 6 plus 10, that makes 4. 2 times 4 that makes 6. Just add these up, makes 9. 2 times 9 makes 18. Just add them up, 29. I started with an x to the third, so my answer is going to be 5x squared plus 4x plus 9, this is my remainder, plus 29 over x minus 2. Let's do another one. Now this one, a little bit rugged. It's out of order. So I need to rearrange, make sure everybody is accounted for, and make sure I get this in the form of x minus c. Well, this is really x to the fourth minus 6x to the third plus x squared minus 6x plus 0. That plus 0 on the end is actually very important. It feels like it's not, but it's going to kill us because we're going to think it's the remainder. You've got to cover all of our bases. Now it's also x plus 6, but I need it to look like x minus c. X plus 6, I need it to look like x minus c. Could I rewrite it as x minus a negative 6? Not the same thing as x plus 6, but it's now in the form of that. My kettle number is now negative 6. Came from right here. Okay? Now, my coefficients, 1, negative 6, 1, negative 6, and 0. Boom. What do we do with the first number? It just falls down. 1. 1 times negative 6. Negative 6. Don't overthink what's happening here. Just add them up. We got to live with the consequences, and maybe I'm going to regret not having my calculator here. Negative 6 times negative 12. Hey, that's kind of cool. I'm going to get a positive number. What's that going to give me? 72. So that gives me a positive 72. I'm regretting not having my calculator. 73. I've got 73. It's 73 times a negative 6. I know it's going to give me a negative number. 73, 6, 18, 1, 42, 43, 438. I hope that's right, or I'll hear all about it. Now then I'm going to add those up. Negative plus a negative, that gives me what? A negative 444. Now I'm hating life. 444 times 6, that's actually going to end up being a positive because it's a negative times a negative, right? Well, that makes 24 last time I checked, which is then going to make that be 26. Which is then going to make that be 26. So 200664. I apologize if I messed up on a math piece there. X to the fourth. I started with an x to the fourth. This is going to go down by 1. So my final answer is, let's see if I can squeeze it in right here, x to the third minus 12x squared plus 73x minus 444 plus 2,664 all over x plus 6, because that's what I was dividing by. One last example to work through here. In this case, not a whole lot to go on here. I've got x minus c, so my c in this case is 1/2. Is that okay if 1/2 becomes my kettle number? Seems reasonable enough. I've got an x to the fourth, an x to the third, x squared, x, and a 1, a constant, so I don't have any holes to fill. I've got a 2, negative 1, 2, negative 3, 1. All I'm doing is pulling the coefficients off of those variables, and then my constant at the end. What happens to the front number? Front number just falls down. That makes a 2. 2 times a half, that makes 1. Negative 1 plus 1. Remember, we're adding here. Negative 1 plus 1, that makes 0. Okay. 0 times a half, 0. Add it up. 2 plus 0, 2. 2 times a half makes 1. Negative 3 plus 1, I think that makes negative 2. Negative 2 times a half makes a negative 1, makes a 0. We just hit the jackpot. I've got no remainder. I like this, even though this one had fractions. I like the numbers much better than the last one. I started with an x to the fourth. So this is going to be 2x to the third plus 0x squared, which I technically could just leave out, plus 2x minus 2, and what do I have for remainder? I could say plus 0 over x minus 1/2, but I'll argue that we don't really need that. Okay, so you've got some work for yourself to do here. Please remember you can go back and watch the video over and over again. Play, pause does work, all that good stuff. And we'll see you in class on Monday. If you have questions, don't be afraid to email me.